Welcome back. Let's start with the demo on OSM, Open Service Mesh add-on with AKS. We are going to execute these 7 steps as part of this demo. The first step is to launch AKS cluster with 2 worker node with OSM add-on enabled. The second step is to validate add-on installation, looking at the ports in kube system namespace. The third step is to check the mesh configuration, expanding the definition file of CRD mesh config, which must have been created by add-on. The fourth step is to take a look at book app microservice architecture and start deploying it. The fifth step is to validate the application by port forwarding the Kubernetes services and access it using browser. Sixth step is to deploy additional version of one of the component of the microservice. And the seventh or the last step is to split the traffic between the different versions of the services. Now let's directly jump into Azure portal and start provisioning AKS cluster. Here we are in Azure. Let's click on Cloud Shell, maximize this. The first step is to create the resource group. I'm going to create the resource group, my resource group, in the location East US. Now I'm going to run the command to create AKS cluster. The command is az create -- resource group, the name of the resource group, my resource group, -- name, the name of the cluster, that is my AKS cluster, -- enable -add-ons, name of the add-on, that is open -service -mesh -node -count 2. So this is going to be 2 node cluster. Let's hit enter. As usual, it will take some time to launch the cluster. Meanwhile, let's have a look onto the book app microservice architecture, which we are going to deploy onto this Kubernetes cluster. This is very simple book app microservice architecture. It has 5 components: book buyer, book thief, book store, book warehouse, and MySQL. Each component of this microservice will be running as pod within my Kubernetes cluster. Book buyer pod can connect to bookstore, bookstore pod can connect to book warehouse, and book warehouse can connect to MySQL pod. Book buyer cannot connect to book warehouse directly, and it cannot also connect to MySQL directly. But book thief cannot connect to bookstore, book thief cannot connect to book warehouse, and it cannot also connect to MySQL. That's how the architecture is, very simple. We have manifest file for each component onto GitHub repo, which we will download onto the Cloud Shell and start applying each one of them one by one to deploy this microservice. Let's head back to the Azure portal and see the cluster status. My cluster is already launched. Let's first get the credential for the cluster. I'll just run az get credential command. Now you should be able to run kubectl get nodes command. I can see 2 worker nodes are running as part of this cluster. That is expected. Now let's run the command to verify OSM add-on installation onto the cluster. The command is az show -- resource -group, name of the resource group, -- name of your cluster, -- query add-on profiles.openservicemesh.enabled. The output of the command is true. It means the add-on is enabled. Now let's verify the ports running as part of this add-on onto the kube system namespace. kubectl get deployment -n kube -system. I can see there are 3 deployment: OSM-bootstrap, OSM-controller, OSM-injector. These 3 deployments are running as part of my add-on. Now let's verify the configuration of OSM mesh. I will run this command: kubectl get mesh config, OSM-mesh-config, -n kube-system, -o YAML. This is the CRD created as part of add-on enablement. This is the name of my mesh config within the namespace kube-system. Under spec section, we have 5 parameters: certificate, feature flags, observability, sidecar, and traffic. Under traffic, there is very important flag here, that is enable permissive traffic policy mode, and that is set to true. As long as this is set to true, there is no traffic blocker. All the ports can communicate to other ports. If you change the mesh config and turn this parameter off, then you would need to enable the traffic between the ports. We will see that in action in a moment. Now let's install OSM client. I have run 4 commands. I have set a variable osm underscore version is equal to v1.0.0. Then I downloaded osm client using curl command and extracted it using tar command within my current working directory. Then I updated the path within my profile file and then I rerun the profile. Now you should be able to run osm command. Let's run osm version. I can see version v1.0.0 is installed. Now let's create 4 namespace to deploy the application. kubectl create ns bookstore, kubectl create ns bookbuyer, kubectl create ns bookthief, kubectl create ns book warehouse. Remember the architecture. The microservice is having 5 components. We are going to deploy book buyer ports inside book buyer namespace and likewise. And book warehouse namespace will have both book warehouse ports as well as MySQL. Let's expand the definition of one of the namespace. kubectl get namespace bookstore-o YAML. This is expected. Now let's enable OSM to all the namespaces. OSM namespace add bookstore, book buyer, book thief and book warehouse. All the namespaces are added to the mesh. Now let's rerun the command kubectl get ns bookstore-o YAML and let's notice the change here. There is one annotation added, openservicemesh.io/sidecars-injection set to enabled, and there is one label also added, openservicemesh.io/monitored-by is set to OSM. Remember, there is a port running in kube system namespace named as osm-injector. Let's verify that once again. kubectl get ports-n cube-system. We have 2 replica of osm-injector deployment running under this namespace. osm-injector will keep on monitoring all the future created namespaces that has annotation as openservicemesh.io/sidecar-injection set to enabled. In this case, it was able to find 4 namespaces which we just created, and it will inject sidecar envoy proxy onto the ports being created on those namespaces. Now let's create a directory /tmp/bookapp and we'll download all the required YAML files there. I will just navigate into this directory. Now let's go ahead and download all the YAML files to this directory using curl command. I have couple of files downloaded. Let's do ls. I have bookbuyer.yaml, bookstore-v1, bookstore-v2, bookthief.yaml, bookwarehouse.yaml and mysql.yaml. Let's go back to our architecture diagram once again. This is our microservice architecture which we are going to build. As I said earlier, so there are 5 components as part of this architecture: book buyer, book thief, book store, book warehouse and MySQL. Initially, I will be deploying one version of bookstore and will enable all the traffic coming from book buyer to bookstore, version v1. I will also enable access from book thief to bookstore, and then I will deploy another version of bookstore and will split the traffic which is coming from book buyer to both the versions. Let's go back to the Cloud Shell in Azure portal. Let's open the first file, bookbuyer.yaml, and understand it. In this YAML file, we are going to create a service account named as bookbuyer, and then we have a deployment having one replica. Under container, we are giving the name to the container as bookbuyer. The image is going to be bookbuyer version v1.0.0, and there is a command /bookbuyer with some environment variable. There are 2 environment variables which we are passing. Bookstore_namespace is set to bookstore. Bookstore_svc is set to bookstore. Now let's open the second YAML file, that is bookstore-v1.yaml. In this file, we have a service named as bookstore. We are exposing this to a port 14001. We are creating a service account named as bookstore-v1, and then we have a deployment. This is very much same as bookbuyer. Here the image is bookstore:v1.0.0. We are running command /bookstore with 2 arguments with 2 environment variable. Bookwarehouse_namespace is set to bookwarehouse. Identity is set to bookstore-v1. This is the second version of bookstore. There is not much difference in between version 1 and version 2. Let's open bookthief.yaml We have service account named as book thief. We have a deployment definition. We have book thief as the image with version 1.0.0. The command is /book thief with 3 environment variables. Let's open the next file, bookwarehouse.yaml. Again, we are going to create a service account named as book warehouse. Inside the namespace book warehouse, then we are going to create a service named as book warehouse and exposing onto the port 14001. And then we have a deployment definition where we are using image as book warehouse version 1.0.0 with the command /book warehouse. And finally, we have mysql.yaml file where we are creating a service account named as MySQL, service named as MySQL, and that is again being created in book warehouse. And this is of type stateful at this time. We are using image as MySQL 5.6. We are passing environment with the root password of MySQL and database named as books_demo with container port as 3306, and we are having volume getting mounted on /mysql-data. This was a quick overview of all the YAML files which we are going to use. Let's start applying these YAML files one by one. Let's first create book buyer service. kubectl apply -bookbuyer.yaml. I got one service account, book buyer created, and one deployment created under the namespace book buyer. Let's run this command to see what all objects are created. We have one port, one deployment, and one service account created. Now let's deploy bookstore version v1. I got service account, and deployment created under namespace bookstore. Let's verify that. I can see pod is running, the deployment, the service account, the service bookstore, and the endpoint. If you would have noticed, there are 2 containers running in each pod we are deploying into the namespaces. One container is your application container, and second container is being injected by OSM-injector. Now let's create book warehouse service. I got one service account, service, and deployment created. Let's verify that. I got a pod, deployment, service account, and service along with the endpoint. And again, I can see 2 containers out of 2 are running. One is your application container and one is being injected by OSM-injector as a sidecar envoy proxy. Now let's go ahead and download a script file named as port-forward-all.sh. Let's open this file first. In this file, we have all the command to run to port forward the pod so that we can access it from the browser. If you want to port forward book buyer service, then you would need to run these 4 commands. If you want to port forward bookstore, then you would need to run these 4 commands, and so on. Now I want to access book buyer from the browser, so I will just copy these 4 commands from here and will run it. It is now exposed on port 7070. Let's try accessing it from the browser. Mention 7070. Click on open and browse. I can see my application. It is book buyer. Total book board 375. From bookstore version v1, that is 378. And from bookstore v2, it is 0 because we haven't deployed version v2 of our bookstore application. Let's close it. Come back to the shell. Now let's deploy the book thief application also. kubectl apply -f bookThief.yaml. I got one service account, book thief created, and I got one deployment created. Let's verify that. I have a pod running, I have a deployment, and the service account. You see there are 2 containers running. One is your application container and one is your sidecar envoy proxy container being injected by OSM-injector. Now let's expose book thief application as well to access it from the browser. Let's open port-forward-all.sh script. These are the set of commands which you would need to run in order to port forward book thief application so that you can access it from the browser. Let's copy it, paste and run it. Book thief application is now running on 7073 port. Let's go here and configure the port as 7073 this time. Open and browse. I can see my application is running. Total books stolen 154, from bookstore V1 158, from bookstore V2 0. Bookstore V2 is 0 because we haven't deployed that version yet. Let's close and come back to the shell. Remember that there was a parameter enable permissive traffic policy mode which was set to true in the service mesh configuration. If you will turn it off, then all the traffic will be blocked by default. Let's try that. I will just edit my mesh config file. We'll turn the parameter off. This one. Save it. That is edited now. Now let's try to access your book thief application. See if it is still working. I can see that it is just stopped at 236. Let's close this tab. Let's try book buyer also. I will configure 7070. Click on open and browse. That is also now stopped at 674. Let's close this tab. Come back to the shell. Now, how do we enable the communication? We will create HTTP route group and traffic target for book buy application to enable communication from book buyer to bookstore version V1. There is another YAML file for that. Let me download that also. Let's open this YAML file and understand it. We have two objects being created here, HTTP route group and traffic target. Under HTTP route group, we mentioned the namespace as bookstore, name of the route group, and under spec section, we have matches as the parameter. Matches is of type array. The first item which we are going to match is books-bot, and the second item is buy-a-book. Under first item, we mentioned path regex /books-bot. Under method, we mentioned what method it should be allowed for, and that is get here. Under headers, we mentioned the header information like user agent and the client app. In this case, we mentioned user-agent value as this and client-app value is book buyer. So we are enabling access to bookstore for the traffic coming from book buyer for get method where the path regex is /books-bot. Similarly, we have another item where we are matching for buy a book, this, where the path regex is this, and method is get. And then we have a traffic target. In the traffic target, we have source and destination along with the rule. So this is going to be my source. I mentioned service account as kind. Name of the service account is book buyer. In the namespace book buyer. Under the destination, I mentioned the kind as service account. The service account name is bookstore-v1 and the namespace is bookstore. Inside the rule, I mentioned the HTTP route group name and both the items of the matches. In short, in traffic target, we are enabling all the traffic coming from the source service account named as book buyer in the namespace book buyer to the destination service account named as bookstore-v1 in the namespace bookstore with this matching rule. Let's go ahead and apply this definition file in order to create HTTP route group and traffic target. I have HTTP route group and traffic target created. Now I should be able to access my book buyer application. Let's try that. I'll click on web preview. Click on the preview port 7070. The service is again working. I can see total books bought 725, that number is increasing. From bookstore V1 729, from bookstore V2 0, that is expected. Let's close this tab, come back to the shell once again. Please remember, I didn't enable the communication from book thief to bookstore yet. So that's the reason I won't be able to access book thief application. Let's validate that also. Let's configure 7073 port. Click on open and browse. That is still not working because we don't have HTTP route group and traffic target created for book thief application. Let's close this tab, come back to the shelf once again. Now let's go ahead and deploy the second version of bookstore application. I can see service account, deployment and traffic target created for bookstore v2. Now the final part of the demo is to test traffic split between two versions of bookstore application. Let's go ahead and download the YAML file for splitting the traffic. We have traffic split -v2.yaml. This is again very simple YAML file. The kind which we are using here is traffic split. Under spec section, we have service, the name of the service, backends, where we define both the service names, bookstore as well as bookstore-v2. For bookstore, the weight is 0. For bookstore-v2, the weight is 100. That means all the traffic should be directed to bookstore version v2. Let's go ahead and save it and apply this YAML file. Now let's get back to the web preview and access book buyer once again. The port was 7070. Click on open and browse. Now you see there is a traffic on v2 and there is no traffic on v1. So the 100% of the traffic is now directed to version v2 of bookstore. Let's close this tab, come back to the shelf once again. If you want to split the traffic in 50-50 ratio, you can just modify your YAML file and here you can just change the weight value. I'll say 50. Let's save it and apply this. Let's access the application once again. Traffic is being directed to version v1 and v2 in 50-50 ratio. Let's close this tab, come back to the shelf once again. Let's modify the YAML file once again. Let's change that to 100. Change the weight value of bookstore-v2 to 0. Save it and exit. Let's apply this YAML file once again. Let's go back to the web preview to access the application. Now there is no traffic being directed to version v2 of your application. All the traffic is being directed to bookstore v1. Let's close this tab, come back to the shelf. That's it for this demo. We were able to split the traffic between two versions of application, bookstore version v1 and bookstore version v2. I hope you liked it. Thank you.